Hi, I'm Adam Pritchard, Assistant Curator of Paleontology at the Virginia Museum of Natural History, and I'm back with another tale of ancient life, this time in the Virginia Museum of Natural History, which is pretty cool. With strict social distancing protocols in place, masks, Lysol, all the gear we would need to fight against the virus, it's time to share some stories from the collections of our museum and to show off some of the fossils in person. Today we return to the oceans, the time and the places where giant whales, megalodon sharks, and sea turtles all survived off the coast of what is now Virginia. But this is not a story about them. This is not a story about animals with backbones. This is the first of my tales of invertebrates. This is the tale. Grab this thing. There we go. Of Chesapecten. Now, by training, I am a vertebrate paleontologist. I do work on animals with backbones. But as curator of paleontology at the Virginia Museum of Natural History, I am in charge of collections that extend far beyond backboned animals. We have an incredible collection of ancient plants, paleobotany, and also invertebrate animals. Now, Chesapecten belongs to a large group of invertebrates called the bivalves, which includes a lot of classic things like clams, mussels, cockles, oysters, and scallops. Now, bivalves are defined by having two components to their hard shell that allow the animal to open and close itself off to the outside world, depending on if it's feeling antisocial or hungry. Now, in a scallop like Chesapecten, this is an example right here, you actually have two asymmetrical valves, two asymmetrical parts to the shell. The left side of the animal, I know this is confusing because it's facing up, but this is actually how it works. The left side of the animal has a prominent rounded convexity to its shell. If I flip that over so the right side is up, it's the right side that's quite a bit flatter across that same curvature. And that right side is the one that sits on the sea bottom when a scallop is just kind of doing its thing underwater. See, inside of these individual valves from Chesapecten, you actually see this huge depression on the internal surface of the shell, right about here. That depression marks the remains of what's called the adductor muscle. The adductor muscle opens and closes the shell. But in a scallop, it is extra huge and centrally positioned, which allows them to open and close their shells with quite a bit of force. And that extra development of the adductor muscle allows scallops to do some pretty amazing things underwater. Yeah, these things can swim. I still can't get over that. The scallop has basically developed a little jet propulsion system whereby it takes in water when it opens and shoves it out the back of its body when it closes, such that Chesapecten could jet through the water. That's an amazing thing to think about. Now, Chesapecten is represented by many different species in the time it's known from the Virginia fossil record, between about 10 and 5 million years ago. One of those species, Chesapecten jeffersonius, named for President Thomas Jefferson, is actually the state fossil of Virginia, which may seem like an interesting choice, a scallop fossil. Why that? Well, that's because among the fossils we have, Chesapecten is an incredibly common fossil in Virginia. I'll show you what I mean by showing you some of the collections that we have here. I know I say this about just about every fossil animal, but Chesapecten was an incredibly successful creature in its day. We have hundreds of thousands of fossils collected from those periods between 10 and 5 million years ago of this critter, of all varying sizes too, babies to adults to everything in between. Still other Chesapecten reached an even more extraordinary size, like this one. Just imagine the adductor muscle, the meat on a scallop at this scale. Truly amazing. And because of that incredible abundance, Chesapecten has had an impact on the history of the people of Virginia as well. There are records of Native American tribes in the area using Chesapecten shells as scraping tools. Makes good sense considering it's a nice, thin, but hard surface. Chesapecten shells have been found collected at the Jamestown settlement by the current archaeological projects going on there. The first illustrated record of North American fossils in European scientific journals are a Chesapecten jeffersonius. And the naming of this shell, originally as Pecten jeffersonius, was during the American colonial period after President Thomas Jefferson. And ever since then, Chesapecten have been entering museum collections here and around the world. Our knowledge of Chesapecten and its importance in the history of Virginian paleontology is largely the work of Dr. Locke Ward, former curator of invertebrate paleontology here at the Virginia Museum of Natural History. Dr. Ward was really interested in the fossil record and in the changing environments of the mid-Atlantic region over the past 60 million years. Although he concentrated a ton of work on the time period between 10 and 5 million years ago. He wanted to know, on a very fine scale, how animals changed in that time period in this specific region. That's not something you can often look at in the fossil record unless you have a really good sense of how old your rocks are and the kinds of animals that lived in there. And for 30 years, Dr. Ward built up an incredible record that is still part of our collection here at the Virginia Museum of Natural History and will be forever, of the changing environment of the Mid-Atlantic region over that period of time. And it's from those collections that we get most of our amazing records of this crazy scallop, Chesapecten. Like seriously, right here in this room with the fossils, I think this is perfect. We have all of Dr. Ward's field notes for the 30 years he was primarily doing collecting. All kinds of information about the specific sites he visited, the sorts of specimens that he collected from each site, and how those sites fit into the history of Virginia's fossil record. Take notes, kids and paleontologists. Everybody should just take notes. That's why you always leave a note. The incredible quantity of specimens we have of Chesapecten and other invertebrates from the collections of Dr. Ward allows us to very precisely examine changes in the shapes of these shells through time. That's a very rare thing in the fossil records that I deal with. Among backboned animals, we usually have, occasionally amazing fossil sites that preserve beautiful skeletons of dinosaurs, reptiles, but they can be quite a bit separated in time and physical space from other fossil sites with similar animals. So it's harder to look at small-scale changes. Not so with things like Chesapecten. In these animals, we have incredibly refined timetables for how their body shapes changed in a relatively restricted area in the mid-Atlantic region of the coast over a period of 5 million years. That's pretty amazing when you think about it. There's a lot of questions still to resolve about Chesapecten's body shape changes, that we know they changed, but why? What exactly drove specific changes? Some make them better to swim. What's the advantage of being a bigger scallop versus a smaller one from earlier in time? And finally, of course, why don't we have Chesapecten today? Boy, they'd be tasty. I'm hungry now, man. For scientists at home right now, here's an assignment for you. Imagine you are a Chesapecten that looks like this one, living under the water in a world full of whales, squids, giant sharks, rays, and sea turtles. and there are predators all around that are trying to crack your shell open and eat you. What adaptations to the shell, what changes would you make to help avoid those predators trying to crack your shell open and eat you? Draw what you would change about this basic shell shape and explain how those changes would help keep you safe from predators. Because remember, you're a Chesapecten in this. You got to think from the brain of a Chesapecten. With that, I'm Adam Pritchard, and I'll be back with yet more tales of ancient life from the collections of the Virginia Museum of Natural History.